So there were a few of you that asked about the final question of question 7 from lesson 3.4. What we want to do is we want to find the position. We know that each time it's at rest, it's going to change directions, right? So if we can find the position at time 0 and then find the position at time 3 where it's going to be at rest, and then it's going to change position again, and then it's going to go in the other direction, and then it's going to stop again at time 6, at 6 seconds, and then it's going to change directions again, and then we want to take it to 18 seconds, and we want to find the position at each of those times and then add up the total position. So let me go ahead and try to help you out with that. If we calculate the position at time 0, we know that the particle is at position 0, right? And we calculate it right here by plugging, taking S of 0. All right, so we get 2 times 0 cubed minus 27 times 0 squared plus 108 times 0. So S of 0 is just 0. So it starts at 0, and then it's going to, I don't know which direction it's going to go in. We could figure out which direction it's going to go in by finding the velocity function, and the velocity function is just the derivative, right? So the velocity function is going to be 6t squared minus 54t plus 108. All right, so if I wanted, I know that at 0 it starts, and I know at t equals 3 it's going to stop. So if I can pick a number between 0 and 3. So one of the things I like to do is I like to draw a number line, and I know that it's going to start at 0, it's going to change directions at 3, it's going to change directions again at 6, and then it's going to continue on from that point. So if I can pick a number between 0 and 3 and test it, I can see which direction it's moving. So if I take, how about t equals 1? If I take t equals 1 and I find v of 1, I would get 6 times 1 squared, which is just 6, minus 54 times 1 is just minus 54, plus 108. And so I'm not really concerned about what the actual value is, what the velocity is. I'm just concerned about whether it's positive or negative. And I know that if I added all of these up, I would have a positive number. So basically what it's telling me is that the particle's moving this direction from 0 to 3 seconds. And then let me test, if I tested a number between 3 and 6 seconds, like 4, so if I took v of 4, I would have 6 times 16 minus 54 times 4, 54 times 4, and then plus 108, and that would give me a, I don't know, let me calculate that. All right, so I calculated it, and it's going to give me a negative value, so that means the particle is moving back this direction. And then if we took a number after 6 and plugged it in, like v of 7, I haven't calculated it yet, but I'm assuming, and it's bad, it's not always safe to assume, so you should always calculate it, but I'm assuming it's going back this direction. So the key is we're going to find out how far it travels between 0 and 3 seconds. So it starts at 0, the position is 0, and then at 3 seconds, we find the position at 3 seconds is going to be 2 times 3 cubed minus 27 times 3 squared plus 108 times 3. So I'm going to pause this and do the calculation. All right, so when I did the calculation, I found out that at 3 seconds, it's going to be at a position of 135. So that means between 0 and 3 seconds, it traveled 135 feet. Now I want to find, so it went this direction, right? 135 feet. Now I want to find out how far it travels between 3 seconds and 6 seconds. So I'm going to find the position at 6 seconds. And so that would be S of 6, which is equal to 2 times 6 cubed, minus 27 times 6 squared, plus 108 times 6. And then I'm going to find out what the position is, and so let me do that calculation. All right, so S of 6 is 108, so that means it travels back to this distance, right? So it's gone 135, and then it goes back this distance to 108. So how far is that? So that's a distance of 27. From there to there is 27. So now it's gone 135 plus 27. And now we want to find out its location at S of 18, because it says what is the position, or what is the total distance the particle travels between the time 0 and time 18. So S of 18 is 4,860. All right, so then it goes back to 108, and then it goes back this direction. I'm only writing that line down here because I ran out of room, but it goes all the way out to, and the scale is terrible, but it goes out to 4,860. So it went from 0 to 135, then it went back to 108, and now it goes all the way back out to 4,860. So what's the difference between 108 and 4,860? It looks like that is 4,752. All right, and so if we add those three together, that will tell us the total distance that it traveled. Again, between 0 and 3 seconds, it went from 0 to 135 feet, and then between 3 seconds and 6 seconds, it went back to 108, position of 108. So that was 27 units it traveled, and then it went from 108 all the way out to 4,860. So that was 4,752 units that it had traveled. So that's a total of 4,914, and that's feet. That's our units, right? So it traveled 4,914 feet.